This world, with its diverse landscape and unique trees, was not crafted by a team of artists, it was generated by an algorithm. Welcome to the world of procedural generation.
Hello, my name is Tico Bedoyan, and for my senior project, I decided to learn procedural generation in game design through Unity. What is procedural generation? Hello. My name is Tico Bedoyan, and for my senior project, I decided to learn procedural generation in game design. I learned Hello.
So, before I could get started actually creating procedural generation, I first had to, learn how to use Unity. So I followed some YouTube tutorials and I did some of my own stuff. The process was okay. There was definitely some frustrating bits, and I was starting to get frustrated with how long the learning process was taking. But one of the most valuable things I did was learn how to use terrains. So here you can see me building a little map out of terrains, none of which is procedurally generated, but soon I was going to use terrains to build my entire map, and it was going to be an integral part of the project. But before I can tell you about building my actual project, I first have to tell you about one of the most critical components of any procedural generation project, and it's called Perlin Noise. Perlin Noise is a type of gradient noise developed by Ken Perlin in 1983. Although what I'm going to tell you about is called improved Perlin Noise, which was created in the early 2000s, but they both generally work the same.
So what is Perlin Noise? Well, in order to understand what Perlin Noise is, first we have to look at what random noise is. So random noise is when we take any input, right? 0, 1, 2, 3, ... and we output a random number, just completely random. You don't know what it's gonna be. And so you end up with these really jagged, unpredictable lines that aren't good for making anything that looks natural and that we'd want to use. So now let's look at Perlin Noise. Perlin Noise takes the same concept where we're taking in an input, 0, 1, 2, ... and we're outputting something that is still somewhat random. But in this case, the randomness looks smooth, and so we can use it to create natural looking things inside of our game.
So one of the very first things I worked on was creating a map outline generator for the project. Basically, what this does is it uses Perlin Noise to create an outline for what the map will look like, and it's totally customizable. All of these inputs on the left and right of the map are different ways of changing the map by changing the math behind the Perlin Noise. You can also toggle whether or not you want to look like an island.
This is Boombox.
Next, I immediately got to work on making it so that my outline generator would then turn into a 3D map inside my Unity project. So basically, what would happen was a bunch of code would get ran, and what was a 2D outline would turn into the 3D map that you're looking at right now. There were a lot of flukes in the way. At one point, I spent 2 whole days solving what I thought was a memory issue, which turned out to be one simple line of code that I could change over time. In the end, I had really optimized code, so But here you can see that this 3D map that's generated by the outline generator can be edited in real time. This isn't a feature that made it into the final version because once the maps get too big, editing gets laggy, but it's a cool thing for me to have along the way. Also, as you can see, there's another layer of Perlin Noise added to the map. This is what causes the ground to be bumpy. This is another thing I can edit in real time, and the final version has smoother, less bumpy ground. I then spent a lot of time working on procedurally generated trees. I don't have a lot of the recordings, but I spent the majority of the project working on this to no luck. Nothing I made looked natural, and nothing I made was optimized enough for me to deploy on a large scale. That is until I ran into something called the L system. The L system was introduced by a biologist, Aristid Lindenmayer, in 1968. Lindenmayer was studying the growth patterns of plant cells and developed the L system as a mathematical way to describe the development of simple multicellular organisms, as well as the branching patterns of plants. An L system is a type of formal grammar. It consists of an alphabet of symbols that can be used to make strings, a collection of deduction rules that expand each symbol into some larger string of symbols, an initial axiom string from which to begin construction, and a mechanism for translating the generated string into a geometric structure. Here's how it works. You start with an initial string of characters called the axiom. This axiom is then transformed according to a set of rules, where each character in the string is replaced by a new string of characters. This process is repeated for a number of iterations. With each iteration, the string becomes longer and more complex. The beauty of L systems is that despite their simplicity, they can create incredibly complex and organic structures. They're often used in computer graphics to model complex shapes like trees, bushes, and other kinds of vegetation. What this meant for me was that if I could find a way to randomly generate the strings necessary for the generation of these trees, in other words, if I could find a way to randomly create sets of words and letters that follow the grammar of these trees, then I'd be set. And although this was no easy task, it gave me a solid way forward. And I spent a lot of time working on it, and I'm happy to say that the trees turned out pretty good. In fact, I think the trees are my favorite part of the project. So yeah, after that, all that was left to do was just randomly place prefabs around the map to make it look more realistic and more detailed. And I also coded an ocean, which is what you can see at the bottom of the outline generator, and also around the edges of the map if you create an island. The ocean also has an element of randomness to it, and it just adds an extra aesthetic element to the game. There's a lot I didn't get to with this project, and that's because I underestimated the scope of the amount of work that goes into making something like this. I encountered a lot of bugs along the way that totally derailed my project, but I was able to keep going, and I'm proud of